I guess. No, I guess. So today we're going to do the what do you call the Western Points midterm paper last year's. We'll be directly jumping off to the part two. Yeah, this is the paper. There are one, two, three, four questions here. I'll give you around 8 minutes. At 6:10, I'm going to discuss. Start doing this question. Let me put a timer first of all. Let's put a timer for 10 minutes. Yeah. Not all 10, these four questions are there. You can see there are four questions here. Start doing these four questions. And I'll be discussing at 8 minutes, 10 minutes, carry 6:13 again. Okay, your time is up. Let's check your answer. Can we have more time? Wait, how many of you are done? Raise your hands up. Let's see how many of you are done. Just for these four questions. You ever got your list? Your hands up based on the time decide. Is there anyone of you who wants more time? Let me know through the chat. Do you want more time? Based on majorities vote. Vinadi देखा क्या इधर? It's 2 minutes enough. Tunak. अरे पाउने. I'll give 3 minutes. Quickly, man, quickly. I'll give you 3 more minutes. Meanwhile, others, if you have any questions, okay, let me know through the chat. I have 3 minutes more. Why is my voice very rough today? Those who joined now, do these questions. I'll start with another 3 minutes. Okay, I'll have a few seconds more. I don't know. No more time. Let's check your answers now. Let's go through the first one and check your answers. 3 minutes flew. Exactly. I think all the answers. Let's check your answers. Obtaining a taxpayer identification number TIN is essential for paying taxes or importing or exporting or obtaining any service from the Inland Revenue Department. Fine. In order to provide TIN, I mean the TIN number, right? In order to provide TIN online for individuals, it is necessary to submit the NIC number, name of the person, contact number, and email address. The relevant person will receive a confirmation of his submission after verification. PIN will be issued to the concerned person through email after the process related to the person's request is completed. Fine, perfect. Now, if you read this scenario, the question is asking you, write down an input, process, and an output. Now, in this case, they have not actually given you, they have not told you exactly about a system. Ah, okay, it is a system, it is a system. It's an online system. Okay, it's an online system that's going to happen to actually give you this TIN number. Now, for you to apply for the TIN number, there are some data you have to give, right? Imagine this is a system. It's system meaning it can be a computer or it can be, let's say, a website, even you can consider a system, right? Now, whatever the things you're going to give for the system, you're going to give to the system. How do you call them as? Are they called inputs, process, or output? How do you call the things you're going to give to the system? Correct. We call them as inputs. On the other hand side, there are certain things you're going to get from this system. How do you call that as? Yes, if you get it from the system, we call them as outputs. Now, there are certain things you're not going to give, you're not going to get, but there are certain actions or there are certain things that are going to be done within the system. What do you call them as? Perfect. They are called the process. Now, as per the given scenario, you can see here this NIC number, name of the person, contact number, and email address. Are these inputs or are these outputs? Are we giving this to the computer or getting from the computer? Input or output? Correct. You can see they are actually inputs. They are things we are going to give for the system. So for inputs, if you have mentioned these words like NIC number or a name of person, again, they have asked you only one input each, but one input only. So either one of these, if you have mentioned, your answer is correct. So contact number and email address. These are some of the inputs we have, which we are going to give for the system. I wrote all of them. That's fine. Okay. But if you wrote one or if you wrote all of them, you're going to get half marks for this. Okay. If you have mentioned either one of these inputs, you're going to get half marks. If you're in all, will they cut marks? No, they will not. Don't worry. Look at the whole question and tell me what are the process we have. Actually, there is only one process which I can see here. What is that process? No, confirmation of submission. It's something we're going to get from the system, right? It's an email we're going to get. So that's not our process. There's one process that's going to happen. Exactly. It's the verification of the application. Okay. Verification. You can, if you just mention verification, also is fine. Verify the word verification is the keyword here. Okay, you can mention verification of application, verification of person, verification of the data entered. All of them are fine. The most precise answer would be verification of application. If the word verification is there in your answer is correct. Verification process correct. As long as the word called verification is there, you get marks. You got it. Just verification is also correct. Okay, that's fine. So you can put there 1 mark there. That's the only process as I can see in this given scenario. And then in terms of output, what is the thing you're going to get from this system? Oh, they have not mentioned that you're getting the team number exact in a scenario. In a scenario, we're going to get something from this system. It is correct. I'm saying apart from it, how is the team going to be sent? Exactly. The confirmation email you can mark as output. Even the TIN number you can mark as output. Huh? TIN is also an output, but basically the TIN is sent through the email. Like for example, let's say they have a application being rejected as issue, then that rejection issue also will be sent through email. Issuing TIN number correct. Receive confirmation correct. Confirmation of submission correct. Yes, all of them are correct. Okay. So if you do the word confirmation email or else TIN, either one of them, you will be getting a half marks. Is that clear? Okay? Issuing TIN number correct. Issuing TIN number to the individual email. That's also correct. Any other questions, anyone? Okay. So always keep this in your mind, okay? This part of how to identify input, process, and output. Right? Let's go for the next one. TIN through email correct. Will we have an input question for sure? Majority of the time they give. So I can't tell whether it's for sure because I have not asked the guy. But let's say there is a 99% probability. Okay. Number two. Yes. Consider the following services of ICT in business sector. Right. So this is regarding again the grade 10 first lesson. One can select what is the question basically? Write the correct term for the above statement from the list given below. Okay. One can select any good and service from the global and local market using internet. Okay. Now, if you're going to buy goods or services from the internet, what do you call that method as? Is it just shopping? Correct. We call them as online shopping. How do you call these applications that's used for online shopping? The type of application that, now, for example, let's say there's a Dara's website, AliExpress website, it comes under category if you take of type of website. And what type does it come? These online shopping websites. The answer means out of the given answers, the answer here. But there's a special name for these online shopping websites. What are they? We also call them as e-commerce website. Now, if you have done commerce, business studies, and accounting in your O levels, you all know commerce means a transaction, which means buying or selling. What you call as commerce, right? So, if you are going to use an online platform to buy or sell stuffs, we call them as e-commerce platform. Okay, all keep in mind. Online shopping can be also called as a e-commerce platform. Correct. But out of the given answers, online shopping is the most suitable answer. M. Connect different business communities who are geographically separated to convene face-to-face meetings while in their own premises. Okay, let's say if I'm going to have, no, even the currently at the moment, I'm in one place, you're in one place. We are geographically separated. Okay, you're in one location, I'm in a different location. And both of us are having like a call here. You can see my face. I mean, I can't see your face, but if you want, you can on the video. I mean, I have locked it. I mean, I have blocked it here, but practically, if you take the application, you are able to do it. So what do you call these types of application as? Like Zoom, Microsoft Teams, all those stuffs. Correct. We call them as video conferencing applications. Okay. So video conferencing is what allows us to have face-to-face meeting even if we are geographically separated. But so it says business. Now, if you take business meeting, mostly in business meeting, it's actually where you're present physically. For example, let's say there is an office. Inside the office, there is a meeting. You can do physical business meeting. But here they are given a keyword here. You're geographically separated, first keyword, and you're going to have a face-to-face meeting at their own premises. Do you normally have business meetings? I mean, apart from video conferencing, if it's not going to happen through a video conferencing part, apart from video conferencing, can you have business meetings at your house? Normally, businesses do they have it at their house? Like I will stay in my house, you stay in your house. I will talk. Can I talk to your face? If there is no video conferencing application, can I talk to your face? If I'm in your house, you're in your house. I'm in my house, you're in your house. Both of us are doing a business, right? So without a video conferencing application, you will not be able to have face-to-face meetings. Got it? Again, read the question properly. We're talking about ICT in business sector. And in business meeting, if you directly mention the word business meeting, it doesn't imply the idea of what do you call this one as well. ICT being used as well. Cannot identify the attitude of face speaking. If it's a call, yes, but if it's a face-to-face video conference, you can. Next, fingerprint scanner helps in recording the times of employees moving in and moving out. Is that relevant for banking? No. Mobile company? No. Business fee? No. Physical trade? No. That's something relevant to human resource management. Normally, if you take your what do you call companies, right? We call this HR department. Human resource department is a department that's in charge for mainly handling employee affairs. What I mean by employee affairs, let's say in a company, you want to hire an employee or you want to maintain the employee details. For example, employees, let's say an employee got accident or something, you want to go and call and inform their family members. You're going to ask this human resource people only. Okay. So normally, this human resource department in a company only is in charge mainly to maintain all the details about these employees in from the part of recruiting them, which means taking them to the company. In part also, what do you call, to paying salaries, everything is done by the HR department. They are the people who mainly handle employees, right? So here they have mentioned recording attendance. Now, if you read the whole fingerprint scanner, blah blah blah, the main part of that is recording attendance. No, including what do you call attendance recording. That's also a part of the HR department or human resource department, right? So this fingerprint scanner is going to be helpful for the HR department, human resource management. When you say human resource, it's mainly talking about the employees in the company. It can be about recruiting, salary settlement, attendance checking, everything. Okay. Ability to withdraw cash anytime, anywhere. I didn't understand HR. HR is actually, now, for example, in your school, have you all heard this word called IT department, finance department? You heard this word called IT department, finance department, all those stuffs, right? Just like that, there is one department in your school, that not in school, in companies mainly, called as HR department, human resource. Okay. Now, if you take a company, okay, some of the human resources involved, the main human resource involved is an employee. Employee works in a company, right? So maintaining all the details about the employees is a task of the company. The company should maintain, let's say, the employees attendance record. The company has to maintain the employees salary things, and employees have to maintain, let's say, HR has to the company has to maintain employees personal details. For example, if they get accident and all those stuff, who should I go and contact? All the details regarding these employees are normally recorded in the company. Now, in a company, there are different departments. We have finance department, we have IT department, we have technical. Depending on the company, it can vary. Okay, from company to company, it can vary. But mostly, if you take majority of the high business companies, they'll have a department called the HR department, and the main purpose of this HR department is to manage employees, right? If you take here the point number in, here we are talking about maintaining attendance, right? So if you're going to manage the attendance, it's a part of a employee's details, right? So maintaining employee details is normally done by the human resource department. So this fingerprint scanner is going to make the human resource part more convenient. Got it? So that fingerprint scanner is going to be helpful for the human resource management. Perfect. Fingerprint scanner, okay, done. Oh, ability to withdraw cash anytime, everywhere. But is that going to come under? Is it physical trade or e-banking? Correct. In physical trade, you have to be present physically. That means if I want to do a trade, if I want to do a transaction, both of us should be in the same place. But if I'm going to be in my place and you're going to be in your house, we can't have physical trade. That is where you can have an e-banking. Okay, e-banking option. For example, you have this. Many of you all have these. Parents might have these banking applications to do bank transfers, all those stuffs, right? So those are e-banking application. You don't have to go and give in the hand of the person. you can directly transfer the receiver's account number. Okay, so the last one is talking about e-banking. So if you match them correctly, L is online shopping, M is video conferencing, N is human resource management, and O is e-banking. Put half marks each. Anyone having any other questions here? But we can't withdraw cash, right? Ability to withdraw cash anytime, anywhere at ATM. Point. You can't withdraw cash in e-banking, correct? It doesn't come under physical trade as well, because physical trade is where you have the receiver present locally. Mm, it can vary depending on the context. The point is valid. Full form of ATM, automatic teller machine. Wait, that's the point. Because we are talking about withdrawing cash from the ATM, not at home, not at transferring money at home. We are talking about withdrawing the cash from the ATM. That's a transaction which you have to go to the bank and do. I mean, go to the ATM machine and do. So, if you're going to go to the machine and do, are you going to have any physical movement now? You're going to go to the ATM machine and do. So, is there any physical movement? Yes, there is a physical movement. So, based on that, actually, ATM machine should come under physical trade. But again, it's a e-banking service. No, it's e-banking service. When you come on e-banking service, my mistake, I'll again come back to that. When you take physical trade, it's mainly about when you take the word called trade, it's mainly talk about buying and selling. So this is mainly about both the person who wants the money and the person who is going to give the money. Both of them are going to meet physically. So when you take withdrawing cash from ATM, in this context, they are not told about giving the money to the receiver. Sender is not giving the money for the receiver. Instead, you're going for the bank and getting the money. Now, earlier days, if you take before ATM machine all was in developed, earlier days, if you want money, what you have to do is you have to go to the bank. Normally, what time does banks are opening? Let's see if you all know that even. What time do bank function? Around 7 a.m. or 8 a.m. to around 3 p.m. as I can remember. 3 or 4 p.m. I can't remember exact time, but let's say around 3 p.m. below. It will vary, but let's say 9 to 3 then. Not so late. Okay, let's take 9 a.m. to 3 p.m. below. Now, earlier days, if you want to withdraw the money as well, you have to visit the bank within this time frame. Only if you go to the bank within this time frame, you can go and withdraw money over the counter. You can withdraw money over the counter. But nowadays, if you want to withdraw money, should you go to the bank within this time frame and withdraw over the counter? No. Nowadays, you don't have to do that because nowadays we have this ATM machine, and ATM machine is actually connected to the internet. Now, for example, let's say there is a machine in Dahiwala and there is a machine in Vellavatta. There is a machine in Dahiwala, there is a machine in Vellavatta. In your card, in your bank card, you have 10,000 rupees. You went to the Dahiwala machine and you withdrew 7,000. Now, how much balance do you have? Initially, you had 10,000. You went to the Dahiwala branch and withdrew 3,000. See, 7,000. So now how much balance you have? Correct. Now you have a balance of 3,000. Now, if you go for the Vellavata branch and try withdrawing again, let's say another 8,000, will it allow you to withdraw this? No, it will not allow you to withdraw. Why? It will be like insufficient bank balance. So that means when you did this transaction at any time, whether it's midnight or whatever time you did this transaction has got updated in some sort of database. Now all your data is stored in a place called database. No? So in some sort of a database, your transaction has got updated. That is why when you went for another bank, I mean another branch ATM, you went for the second branch ATM, that is why it got rejected saying you don't have any bank balance. Your bank balance is insufficient. So you can see all these data are updated electronically. The data is updated. So when you withdraw for money from one place, quickly it's updated in the system saying, okay, this bugger's bank balance, go and reduce 7,000 kila. It's updating. It's all interconnected. Everything is connected globally. So even if you go for a different country and try withdrawing also, still it will be like, okay, you don't have enough of money, right? So therefore, ATM, apart from what you call online banking applications, online banking also comes under e-banking. But apart from online banking applications, even ATM comes under e-banking. Got it? This is the main reason. Rehan, I think that's was it out, right? Okay. If there's any other questions, drop in the chat. Roman number 3. Okay. Convert the hexadecimal number 7DA into binary. Let's convert. Yes, I give. So we have this number called 7DA, and they have mentioned it's a hexadecimal number, and they want us to convert this to binary. Normally, if you take a hexadecimal number, tell me, hexadecimal number is a how many bit number system? Is it a 3-bit number system, 4-bit number system, 5-bit number system, or how many bit number system? Correct. Another name for hexadecimal number system we normally call this a 4-bit number system. Keep in mind, another name for hexadecimal number system is 4-bit number system, right? Which means every hexadecimal character, okay, we have three characters, 7 is one character, D is one character, A is one character, okay? Behind each of these characters, there are 4 bits hiding. Now, what do we mean by the word called bit? What does this word called bit mean? The word bit means binary digit, one binary digit. Okay, a binary digit is what you call as a bit, right? So what we are meaning by 4-bit number system means to represent this value, to represent this value, and to represent this value. We are going to use 4 bits each. To represent number 7, we are going to use 4 bits. To represent letter D, we are going to use 4 bits, and to represent letter A, we are going to use 4 bits. Now we are going to figure out what those 4 bits are. What those 4 bits are. Normally, if you have 4 bits, for example, let's say these are 4 bits we have. Okay, normally if you have 4 bits, you can find the value these 4 bits are representing by multiplying each of these digits. So these are 4 bits there. You can multiply each of these digits by something called as a place value. If you multiply each digit by its place value, you can get the value of that number, right? Normally, if you take a binary number to find the place value, you multiply each digit by 2 to the power 0, 2 to the power 1. These are place values. 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. These are what we call as place values, right? Now, for example, if you take a decimal number, let's say I have a decimal number like this for you. In decimal numbers, we say, right, this is 10 to the power 0 is 1, 10 to the power 1 is 10. We say that this is called the ones place. This is called the tens place. That's what you call as a place value. Hundreds place, thousands place. In decimal numbers, we say, right, just like how we have ones place, tens place, hundreds place, thousands place in decimal numbers, in binary numbers, you can find the place values by taking 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, like that till you find the place value, right? So I mentioned here the values. That's 1, 2, 4, and 8. Now, how you find the value of this number is you will be multiplying every digit by its place value. Okay. So if you multiply every digit by its place value, 8 times 0 is 0, 4 times 0 is 0, 2 times 0 is 0, 1 times 0 is 0. Okay. And you can tell the value of this number is 0. But imagine the binary number was like this. If the binary number was like this, now it's going to be 4 times 1 and 2 times 1. So 4 times 1 is 4, 2 times 1 is 2. So answer of that value of the number will be 6. Okay. So based on this idea, we can, you can incorporate this idea here and tell, okay, if every digit is going to be represented by 4 bits, if you want to figure out what those 4 bits are, there's a small shortcut. Below every number, just write these 4 bits place value. There is 1, 2, 4, 8. 1, 2, 4, 8. Just below every digit, write the 4 bits place value. Then you see how can I form that number using these 4 bits. Now, for example, if you take hexadecimal, the letter A represents how much? What is the number this letter A is representing? Correct. It's representing the value of 10. And D is representing how much? A, B, C, D. 10, 11, 12, 13. Okay, D is representing the number 13. Now, if I want to form the number 10, okay, to form the number 10, out of 1, 2, 4, 8, what are the numbers I have to add together? Correct. To form the number 10, I have to add the number 8 and number 2. Similarly, to form the number 13, what are the numbers I have to add together out of 1 to 4, 8? Correct. 8 plus 4 plus 1 will give you 13. And to form the number 7, what are the place values I have to add together? Correct. It's 1, 2, and 4. So what you're going to do is circle the place values you need to form the respective number. To form the number 7, I need 1, 2, 4. To form the number 13, I need 8, 1, 4, 8. To form the number 10, I need 1, 2, 8, and 2. Once you do that, the numbers you need is that below the numbers you need, write 1. Below the numbers you don't need, write 0. And now if you notice, the number 7 can be represented using these 4 bits. These are the 4 bits used to represent number 7. These are the 4 bits used to represent number 13. And these are 4 bits used to represent number 10. And if you want to find the whole value together, if you want to find the value of 7DA16 in binary, you just put all of these values together. So that's going to be 0, 111, 1101, 1010 base 2. What I've done here is I have just merged them together. Okay, I've just merged them together. So once you merge them together, you can see there's a bit in the left side corner. If you want, you can cut that down. Because when there's a 0 in the left hand side, it's not going to change the value. And this is how I found the answer here. So first thing what I did is below every hexadecimal, I took every hexadecimal digit separately. After I took every hexadecimal digit separately, below every digit, I wrote these numbers for 1, 2, 4, 8. 1, 2, 4, 8 and 1, 2, 4, 8. Then what I did is I circle numbers I need to form the respective digit. Okay. To form the number 7, I want 4 and 2 and 1. To form the number 13, I need 4 and 8 and 1. To form the number 10, I need 8 and 2. After I circle the numbers I need, below the numbers I need, I wrote 1. Below the numbers I don't need, I wrote 0. And then I just join them together. Tell me, I clear here how I converted 7DA base 16 to binary. Got it, all of you? So answer is 3, 4, 5. 5 ones, 0, 1, 0, 1, 0. If you got this answer correct, put 1 mark. You can use any method. Huh? This is one of the method I gave you. There are other methods as well. So as long as your calculation steps are fine, also it should be considered. Can we just try the BCD code? They're not even asking the BCD code. They're talking here about hexadecimal to binary. Which world are you in? Okay, next. If the decimal ASCII, so if the following ASCII binary code represents true, then write the ASCII binary code representing yes. Okay. Normally, if you take ASCII, ASCII is a way you can use to represent characters. Now, for example, we learn binary, octal, hexa, decimal. These are all used to represent numbers. But if you want to represent other characters, for example, it's letters, symbols, and all those stuffs, images, all those stuffs, we have something called as coding systems. Like you would have learned a coding system called BCD, EBCDIC, Unicode. There are several coding systems. Here they're talking about ASCII coding system, right? If there's a question asking binary to octal, then place value is 10. No, binary to octal you group into 3 bits by 3 bits because octal is a 3-bit numbers. When you get a question, I'll show you. Anyways, so if you take ASCII, it's a type of coding system where what we do is we assign a digit. We'll assign a digit for every character, and we will convert this digit into binary. The value of this digit we will convert to binary and write. Now, for example, if you take this letter called true, this word called true has how many characters? Characters mean like how many letters? Yes, TRUE. There are 4 characters. So this is the binary representing letter T. This is the binary representing R. This is the binary representing U, and these are binary representing the letter value E. Right? These are respective values. Okay. So let's say you want to find the value of yes. You should know what is the binary used to represent Y, what is the binary used to represent E, and what is the binary used to represent S. There are 2 methods. If you have by-hearted ASCII, then you might know the capital letter A is equal to 65. The digit used to represent the character A is 65. So based on this, you can figure out A is 65, B is 66, C is 67. Likewise, you can figure out how much is Y, how much is E, how much is S. This is one method. But let's say you can't remember that and you're going to depend on these data, then there is a method for that as well. Okay. Let's take, for example, if you take the letter E, there's a small trick you can see. If you take the letter E is all the value of ASCII value of letter E is already given here. So we don't have to find it again. Okay, we don't have to find it again. Directly we can tell, okay, if you take the word yes, you can tell it, if you take the word yes. The ASCII value for S is already given there. It's what? 1000101. We have already value of E. We have to find the value of Y and value of S. Tell me out of T, now let's say I'm going to find the value of S first, okay? If I'm going to find the value of S first, tell me out of T, R, U, okay, or E, which letter is more closer to S? I hope you all know alphabets. Which letter is more closer to S? Yes, S is between R and T. S, P, Q, R, S, P, Q, R, S, T, R, S, T. Yeah, okay. RST, no. So S is between R and T, RS, PQ, RST, no. So I can either convert R or I can either convert T. Let's first of all convert now RST. I'll convert R below because R is first. No. Let me find what is the value of R in decimal. Now, if R in binary is basically 1010010, let me first of all convert this to decimal. Okay. You all know how do you convert decimal? No? Multiply each digit by its place value. So 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6. Okay. Wherever there is 0, cut the place values, add the sum of remaining. So 64 plus 16 is 74, 78, 79, 80. If you add the values together, you can see you are getting the number 80. 64 plus 16 plus 2. Okay. That's going to give you 80, 64, 70, sorry, 82, 82, 82, 82, 82. Okay, that's going to give you the number 82. So now we know the value R or letter R, the value of letter R is actually 82. Now, based on that, tell me if R is going to be 82. Now, as per the alphabets, you all know this is how the alphabets work: P, Q, R, S. So, if R is going to be, let's say, RST, okay, if R is going to be 82, Q is going to be 81, P is going to be 80. So, what will be the value of S? Correct. S is going to be 83. The next value, 83. So, what you can now do is convert 83 to binary, divide by 2, 2 times 41 is 82, 1 remains. 2 times 20 is 41 remains. 2 times 10 is 20, 0 remains. 2 times 5 is 10, 0 remains. 2 times 2 is 4, 1 remains. 2 times 1 is 2, 0 remains. 2 times 0 is 0, 1 remains. You do this division until you get 0 and write the what you call binary numbers from down to up. Okay. So if you write the numbers from down to up, you have there the answers. S is equal to 101 double zero double one. Tell me, are you clear on how I found the value of S? Correct. So if 83 is S, T is going to be 84, U is going to be 85, V is going to be 86, W is going to be 87, 88. And how much is going to be the value of Y? Correct. The value of Y is going to be 89. The same process you're going to do to find the ASCII value of Y, you convert 89 to binary. So that's 44, 1 remains. 2 times 22 is 0 remains. 2 times 11, 22, 0 remains. 2 times 5 is 10, 1 remains. 2 times 2 is 4, 1 remains. 2 times 1 is 2, 0 remains. 2 times 0 is 0, 1 remains. And if you write the numbers from bottom to top, write the remainders, okay? We write all the remainders from bottom to top. The last one we have there is 1, 0, double 1, double 0, 1. Okay. Now, if you notice here, I am representing the letter Y using 7 bits, letter E using 7 bits, letter S using 7 bits. So you can tell the letter S is equal to 1011001, 10001, 01, 101, double 0, double 1. If you mention base 2 also it's correct. If you just leave it as also it's fine. But this is how you find the value of S. Tell me, are you all clear on how I did this question? Got it all here? Okay, I told you there are two approaches. One is if you all can remember ASCII, you will know A is 65. From that, you can figure out how much is Y, how much is E, how much is S. Can we convert this in 1 to 4? What do you mean? That's what I've done. For the base, we need to put ASCII, right? ASCII is not a base. When you say 7, ASCII is a number system that is used to represent characters in 7 bits. What do you mean by the word 7 bits? 7 binary digit. So these 1, 0, blah, 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 they are binary digits, man. So what is the base of binary number? 2, right? ASCII is a 7-bit number system. What is the ASCII for simple A? I can't remember. As I can remember, simple A is 97, I guess. I can't remember. 95 or 97. Can't remember. Forgot. Should we divide by 1 by 2 also? I mean, can't we stop dividing when we get 1 at last? Then the definition is wrong. What was my definition? I said divide and write the remainders. So if you're going to stop at 1, then you're writing a remainders and the quotient both. These are called remainders and these are called quotients or quotients. So if you don't divide until 0, then as per the theory, you're wrong. You'll be writing all the remainders and the last quotient. That's why I do until 0. 65 without dividing by 2, I ask you 1 to 48, can we do that? You can do, but you can't do it until 1 to 48. You have to go till 1 to 48 ASCII is a 7-bit number system. So if you're going to follow the 1 to 4 method, you go like this: 1, 2, 4, 8, 1, 2, 3, 4, 5, 6, 1, 2, 4, 8, 16, 32, 64, 128. 1, 2, 3, 4, 5, 6, 7. Sorry, 64. ASCII is a 7-bit number system. Just like how hexadecimal is a 4-bit number system, ASCII is a 7-bit coding system. So if you want to follow the 1 to 4 method, your right is from 1 to 64. You write from 1 to 64, and you can follow the same method, how to form the number 83. So 83 can be formed by taking 64 plus 70, 16 plus, like that you can find. But that's not the syllabus, this method, but you can. Won't the last zero come? ASCII is a 7-bit number system, and I said we write only the remainder. You divide until you get 0, and you write only the remainders, and it should be having only 7 bits. Count and see how many bits I have in Y, how many bits I have in E, and how many bits I have in S. Always try doing until 0 and write the remainders. If your number has less than 7 bits, then you add a 0 in front. But here you can see all of them have 7 bits. 1, 2, 3, 4, 5, 6, 7. Yeah. Then give the total marks if you do the 1 to 4 method. Yeah. As long as you follow any method, it's just a method. One problem has many solutions. We call that as what? All the possible solutions for a problem. How do you call that as? Let's see if I can remember the word. You learned in the grade 11 first lesson. In other words, is a method must. If they ask you the method, yes, always try doing giving the method. You have enough of time. All the possible solutions for a given problem is called solution space. Sorry, one of you gave the answer. Only in ASCII we divide it till 12. Everywhere you divide till 0, man. If you want to convert something from decimal to binary, divide until you get 0 and write the remainders from bottom to top. Simple. Any other questions? So yeah, this is the final answer. This downward. These are the final answer. Anything from decimal, if you're going to convert to something else, decimal to binary, decimal to octal, decimal to hexadecimal, do the division until you get 0 as the quotient. And then you write the remainders from bottom to top. Simple. Okay, so if you got this as the answer, put 1 mark there. Again, the base is not important. What's the answer of the question you asked from us? Sample space, sample space. Sample space are all the possible solutions for a given problem. Will they ask ASCII value for the simple letters also? Again, always ASCII questions, they'll give you a hint. Now here you can see they gave you the value of T, R, U, and E. So if they're asking for simple letters, then they'll give you the hint as well. They will give you anyways, or 99% of the time, always ASCII will give you a hint. So what you do is you convert that from binary to decimal, like this, which I did here. Not here, where I did here. I found that R is equal to into. And once you found that R is equal to into, you can figure out the remaining stuffs. Same thing with simple letters as well. If they give you one simple letter, convert that to decimal, and then you can figure out the previous simple letters and after that simple letters. Okay, so 1 mark for the Roman number 1. So 1 mark for question A and 1 mark for question B. Anything else? Any other clarifications around? Okay, Roman number 4. Write the truth table for the output at X. Right. I'll do it here itself. If you take this AND gate, the output of this AND gate is A dot B. Because you can see there are two inputs. One of the input is A, other input is B. And the symbol we use for AND gate is dot. So output is going to be A dot B. Now, if you take this NOT gate, the input for this NOT gate, you can see it's actually A. A is the input for this NOT gate. It's not the correct way to draw like this. The correct way you're drawing, let us show a small jump, but that's fine. Okay, the correct input here, what they're meaning is A. When A goes to the NOT gate, A becomes A dash. If you take this NOT gate, the input for this NOT gate is A dot B. When A dot B goes to the NOT gate, it will become A dot B whole thing dash, because NOT gate a dash is added to your input. So here the input is A dot B. So we write A dot B whole thing dash. And if you take this OR gate, the input from the top is A dot B whole thing dash. Input from the bottom is A dash. For OR gate, the symbol we use is plus. So the output is going to be something like this. First of all, tell me, are you all clear about that? Are you all clear about the Boolean expressions I got for each of these gates? Clear? Can we take as B dash? No, it's not correct, but we can't take it as B dash, A dash. Okay. Now, when you're drawing the truth table, you have to draw one column each, first of all, for your inputs. Now, if you look at this whole circuit, A is one input, B is one input. So, draw two columns like that. Next, draw one column each for every output you have. So, A dot B is one output, A dot B whole thing dash is another output, A dash is another output, and what do you call A dash dot, sorry, A plus B whole thing dash plus A dash is another output. So what I did here is input I wrote one column, and for every output I wrote another column. Is this process clear, all of you? Understood what I did here? For every input I wrote one column, for every output I do another column. Next what you do is, yes, bracket is a must. Okay. Next, sorry, A dot B, my bad, A dot B. A dot B. Yeah. Next, what you do is you what you call figure out how many rows are going to be there. Okay, the number of rows we call that as a possible combinations. You can figure out the number of possible combinations using this equation called as 2 to the power of number of inputs. Now, if you look at this circuit, how many inputs do we have? How many inputs do we have? Yes, A is one input, B is another input. So total we have two inputs. So their possible combination is going to be 2 to the power 2, which means there could be four possible combinations. Okay. So what I'm going to do is I'm drawing here four rows. 1, 2, 3, 4. Okay, I drew four rows. Now I start filling this table. Okay. First of all, go for the right side corner input. You can see there are two inputs. Go for the right side corner input and just write 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay, just go and write until the last row. Just the same pattern. 0, 1, 0, 1, 0, 1. After done with the right side corner input, go for the next input and double it. So here I'm going to put two zeros, two ones, two zeros, two ones, two zeros, two ones to go. If there was another input, okay, again I'm saying if there was another input, double it. It's going to be four zeros, four ones, four zeros, four ones. Again, you'll be doing four zeros and four ones only if there was another input. But here only two inputs, so I went for the right side corner one, 0, 1, 0, 1, 0, 1. Next one, two zeros, two ones. Just double it. Is that clear, all of you? Understand how I found these combinations? First in one, try 0, 1, 0, 1, 0, 1. Next one, double of that. So two zeros, two ones. Now you will start filling the table. Now AND gate is where all the inputs has to be 1. Right? Now in the first scenario, you can see A and B both are going through the AND gate. Are all the inputs 1 in the first combination? Are all the inputs 1? No. So AND gate is going to give you 0. In the second combination we have, is all the inputs 1? Again, no. So it's going to be 0. In the third combination, are all the inputs 1? Zara, I'll tell you in a while. Okay, wait. No. So I'm going to put 0. In the last combination, are all the inputs 1? Yes. So therefore, I'm going to mention 1. Keep in mind, AND gate works in such that if all inputs are 1, output is going to be 1. Right? So you can say, oh, the last combination, all the inputs were 1, so output is 1. I will clear how I fill that column, all of you. Understood how I fill this? Where are you at the hospital? Because I can hear the hospital sound. I am not at the hospital when it sounds. That's why the whole environment is different. Those buggers in the other room. I came to teach them Python. Okay. A dot next column we have is A dot B whole thing dash. Now A dot B whole thing dash means we are saying we have found here A dot B. No, we want the opposite of A dot B. A dot B is whole thing dash between opposite of A dot B. So if you have 0 here, we're going to have 1 here. If you have 0 here, we're going to have 1 here. If you have 0 here, we're going to have 1 here. If you have 1 here, we're going to have 0 here. It's just the opposite is being written here. Okay. So keep in mind in what do you call A dot B whole thing dash. What I'm meaning here is the value of A dot B, opposite of that is called A dot B whole thing dash. So if A dot B was 0, A dot B whole thing dash is 1. So I have written respectively the truth table. Now when you say A dash is the opposite of which column? Exactly. A dash means opposite of A. So if A is 0, A dash is going to be 1. If A is 0, A dash is going to be 1. If A is 1, A dash is 0. If A is 1, A dash is 0. This is how you fill the A dash column. Tell me all of y'all, you'll understand how I fill these two columns now. Got it? Okay, perfect. If you look at the last one, you can see we have A dash, A dot B whole thing dash, which is talking about this column. And we have plus A dash, which means this column. Now, these two columns are being compared using plus means what is the gate we are going to use? If these two columns are going to be compared using plus, what is the gate we're going to use? OR gate. Correct. It's the OR gate. Now, OR gate works in such that if all inputs are 1, output is 1, or else any input is 1, output is 1. All or is it any? How does OR gate work? OR gate will give you 1 in each scenario. If all the inputs are 1, or if any of the inputs are 1. Exactly. OR gate gives you 1 if any of the input is 1. Right? If any input is 1, OR gate is going to give you 1. Now, if you look at the first instance, comparing A dot B column and A dash column, in the first instance, is any of the inputs 1? Yes or no? Checking is any of the inputs 1? What will your answer be? Yes or no? Yes. So I'm going to mention 1. In the second instance, is any of the inputs 1? Again, yes. So I'm going to mention 1. In the third instance, is any of the input 1? If you take this scenario, is any of the inputs 1? That means we are going to compare here A dot B dash and A dash. Is any of these inputs 1? Yes. So it's going to be 1. In the last instance, is any of the input 1? No. In the last instance, no. So last instance, it's going to be 0. Okay. So this is going to be how you fill the last column, 1, 1, 1, 0. Tell me, did you understand how I fill this truth table, all of you? Yes or no? Okay, one of you asked me about that columns. Let me show you something else. I said you can find the possible combinations using this equation called 2 to the power n. No? Tell me, if there are 3 inputs, then how many combinations can be formed? Let's say there's input called A, input called B, input called C. How many combinations can be formed? Yes, it's going to be 2 to the power 3, and that's equal to how much? 8 combinations can be formed. So now if you have 3 inputs truth table, you'll draw a truth table with 8 rows. So 1, 2, 3, 4, 5, 6, 7, 8. First of all, tell me, are you clear with this part about figuring out the number of rows? Who had the doubt earlier regarding how to fill this table, how to fill the inputs. Okay. So once you know the number of what you call rows that are going to be there, now you go for the right side corner row, right side corner input. Okay. So let's say this for the circuit video. Let's say this is the circuit. Now you go for the right side corner input. The right side corner input is C. Now you start filling that C column with just this pattern of 0, 1, 0, 1, 0, 1, 0, 1. Can I just go in that pattern? Okay. 0, 1, 0, 1, 0, 1. Thank you. Just go in that pattern. And after you go in that pattern, the next column, okay, double it. So here, if you're going to go 0, 1, 0, 1, 0, 1, here you go two zeros, two ones, two zeros, two ones. And the next column, again, double it. So here it's going to be four zeros and four ones. So here, if it's one, double of one is two. Here, if it's two, double of two is four. So if there was another column, instead of four zeros, four ones, you'll be using eight zeros and eight ones. That is how you fill these inputs for the truth table. Is that clear, all of you? Understood? Okay, perfect. Anyone having any other questions based on what we did here? Others, drop me your marks. So basically, how the marks is broken is if A and when A and B was zero, 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 one, one, zero, one, zero, one, 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 zero. Okay. When A and B was zero, if the output was one, you get one mark. Sorry, half marks. When A was 0 and B was 1, if you wrote 1 as output, again half marks. When A was 1 and B was 0, if the output was 1, if you answer like that, you get half marks. When A was 1, B was 1. When both of them are 1, if the output was 0, again half marks. That's how your marks is broken. Half, 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 half. ASCII meaning American Standard Code for Information Interchange. Just like how we have binary, octal, decimal for representing numbers, we have ASCII, EBCDIC, Unicode, all of them to represent other characters like letters, symbols, and all those stuffs. Okay, this is a minimum requirement. If you have wrote this is more than enough. Better write like my table, which I wrote down. But if you wrote only this is also enough. Now tell me, out of 8 marks, how many marks you all get? Out of 8 marks, how many marks you all get? Good. I know for the last 3 or 4 weeks, we're doing MCQs. Anyone having any questions here? Yes, Sikra. Now 17, 18, 19, 20, 13 minutes. 13 can do 4. Yeah. Do these two questions. I'll give you all 4 minutes. Quickly do these two questions, all of you. Three, two, one. Okay. Okay. Stop your working. Let's check your answers. First question. Fifth question. Explanations of guided and unguided media. Guided means wired, and unguided media means a wireless medias. Represents A to D, and the exact names of them are given in the following table. Match them correctly. Let's check. The outer cable, like a copper net, makes a magnetic field around the center cable. This is used for TV antenna cables. Okay, in TV antenna cables, which type of cable is used? Is it the first one, second one, or the third one, or this fourth one? Yes. For TV antennas, those cables, the copper cable we have there, they are called coaxial cables. So A is going to be coaxial cable. B, data are transmitted using the reflection of light. Which one? Is it one, two, three, or four? Correct. Reflection of light, the data is transferred means that's going to be the fiber optics cable. Keep in mind, fiber optics is the fastest data transmission medium. I think you would have learned that in science as well when you were doing that reflection lesson. When you were learning about total internal reflection, have you learned that? Sorry, optics. Okay. So on a total internal reflection, if you have learned, that's the same idea, that's the same concept that's being used inside these fiber optics. Okay. But you don't have to know that in IT. That's a science thing which you should know. Anyways, keep in mind one in IT, what you should know is the data is transmitted not through electronic signals. Huh? Now, if you take all other wires, the data is transmitted as electronic signals. But if you take fiber optics, that is only medium where data is transmitted as a light, reflection of light. Next, flexible and cost effective and suitable for data transmission up to a maximum distance of 100 meters. What is it? Small distance? Yes, that's going to be the UTP, unshielded twisted pair. Shielded twisted pair, unshielded twisted pair, both the distance are going to be the same only, right? So if you are going to what you call yeah, if you're going to transfer data using the unshielded twisted pair, it's 100 meters or more than 100 meters. I can remember it's up to 100 meters. I'll check this one. But yeah, C is talking about the UTP cables. No, cables doesn't have a limit. Infrared is smaller than that. Infrared is smaller than 100 meters. Like you can trans only for wireless medium there is a limit. For wired medium, as I can remember, there is no limit because it's a wire basically. Um, Let me process this. Let me just check the tube which how much I gave you. Generally, wires doesn't have a limit. Did I give a limit? Why is it taking time to load? Maximum 100 kilo are given. Then fine. I have to double check why. I can't remember why I forgot. Okay. Ah, wait. It is suitable, I think, for maximum 100 distance, but you can transfer more than that. Because the data will not get stopped, data will not break. Okay, it won't get broken. You can transfer data. If it's more than 100 meters, the speed will be slow. I think that's the main reason we have 100 meters, we limited it. Because data will get transparent. There is no data block happen, it will not happen. Only thing is the data transmission speed can vary when it's more than 100 meters. So anyways, that's going to be the UTP cable only. But I'm still having a question mark on 100 meters. I just double check that here and see. But yeah, that's a point. Keyboard and mouse can be connected without cables. It should be Bluetooth, not infrared. It's a typing mistake. Infrared, there's an issue. Infrared, the sender and the receiver, both of them have to be face to face. Okay. In what do you call the infrared, the issue we have there is okay. Okay. The issue we have there, send and receive has to be face to face. But now, for example, this if you're going to connect your keyboard or mouse wirelessly, you will be getting a cable. You'll be getting a small adapter like this. Okay. Now my mouse is wireless. I connect my wireless mouse using the adapter. Now, normally, if you are going to use it like this, will you keep your mouse and adapter like this face to face and use? Like move the laptop like this face to face. Is that how you might use the mouse? Technically, no. So actually speaking, I mean here we there on the only option we have is infrared. But actually speaking, majority of these wireless Bluetooth, wireless keyboard and wireless mouse, majority of them they don't work in infrared. They work with Bluetooth. But I'll connect D for infrared here because that was a given option. But keep in mind, normally wireless keyboard and wireless mouse, they don't use infrared. Have you used AC remote or your TV remote? In AC remote, yes, AC remote and TV remote we use infrared. That's why always AC remote, TV remote, you have to keep facing to each other. Like if you turn the remote upside down and click, it will not work. You should make sure that sender and receiver are face to face. Only if sender and receiver are face to face, it will actually work. There is a radius limit as well. Anyways, if your answers are correct, put half marks each here for A, B, C, D. Anyone having any other questions here? Bluetooth is radio waves, right? Infrared is also radio waves. No, infrared no. Bluetooth is radio waves. Bluetooth and Wi-Fi is radio waves. Infrared is a different type of wave. Bluetooth and Wi-Fi comes under radio waves. Okay. Next, the last question for the day. Consider the following student table in a DBMS. Using the above table, following queries designed to obtain student paid table. Draw the output of the student paid table that appears blah 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 blah. That's wrong actually, Hannah. Practical is wrong. Anyways, if you look at this, what you call database given here, they have mentioned the word called query. In a DBMS, this word called query means it's a part in DBMS that's we used to retrieve data. Retrieve means obtain data. Now, in a database, so in a table, you have several data. No? If you want to obtain this data, we use something called queries in database. Normally, if you are writing queries, you can write queries using a coding language called as SQL. If you want to write queries, which means if you want to obtain data from a database, you can write SQL queries because it's a coding, it's programming language. Huh? Using a programming language called SQL, you can write a code and you can retrieve the data. But without using SQL query, okay, which is like coding, you can get this data from a graphical user interface as well. You can get this data from a graphical user interface. That is what they are given in this question. You can see there's a column called field, or sorry, a row called field. So they have mentioned admission number is one field, name is one field, fees is another field. Here they have mentioned. Then you can see there's another what you call row called table, which table are we referring to? So you can see student table, student table, student table. Next, another one we have something called a sort. Are we sorting this? Now, normally, if you're sorting the data, you can sort based on two things: ascending order or descending order. That is not done here. And third thing you can see here is, so the fourth thing you can see there's mentioned something called show. That means, do you want to show this field? And last, you can see there's something called criteria, which means are there any conditions? Now you can see when we are retrieving this data from the table, we are asking us, we want the admission number field, and we are saying we want the name field, and we want the feast field. We want these three fields from the database. And we want the admission number field from the student table, name field again from the student table, feast field from the student table. These are the three fields we want from the student table. And nothing is mentioned about sorting the data. Okay. But you can see the tick mark in front of them. What we mean by that is you want this field, you want to show this field as well as they want us to show this field. We want all these three fields, that is admission number field, name field as well as fees field. We want all these three fields to show. Last thing on the criteria you can see, we have mentioned here criteria of greater than or equal to 5005. Now this criteria, have we mentioned it for all three fields or have we mentioned it only under fees? Look at this table nicely and tell me, we have mentioned the criteria for all three fields or have we mentioned the criteria only for one field? I mean only the fees field. Yes, you can see this fee criteria is mentioned. This thing called criteria, you can see it's mentioned only for the fees field. So what we are going to do here is when you're obtaining this data, now queries used to retrieve data. I said no, obtain data. No, when you're obtaining data, you're going to obtain this column, and this column. But when you're obtaining the fees column, one condition you're going to check is the value greater than or equal to 1005. You're going to check this condition. This condition is greater than or equal to 1005. You're going to check that condition. Now, if you're going to check is the value greater than or equal to 1005, tell me, will is a first record acceptable? Will you be retrieving the first record? Is the first record's fees greater than or equal to 1005? Yes or no? Is the first record, right? So in this first record, is the fees greater than or equal to 1005? Yes or no? Yes. So we will be getting that record. How about the second record? In the second record, is the fees greater than or equal to 1005? Yes or no? Is a fees greater than or equal to 1005? Yes or no? Yes. So when we are obtaining the data, we will get the first record, we will get the second record as well. Will we be getting the third record? In retrieving, will we be getting the third record? No. Because you can see, when I'm going to check is the fees greater than 1005, it will be like, no, the fees is not. So we are not going to get this record. How about the last record? Will we be getting the last record? What is it, Aisha? Yes, we will be getting the last record. We will be getting the last record. So, how for this answer, what you should do is you should draw a table with the three columns: admission number, name, and fees. Okay, you should draw it like this. The admission number, name, and fees, but without that specific row. Well, again, draw it here. Should draw a column called admission number. The same spelling name should be there. Spellings are wrong, you don't get marks. Admission number, name, fees, 101, 102, and 104. Jayani Nipuni Senaya, and the fees is going to be 1005, 1750, and 2000. This is how your answer should be. We mention all three fields name, and the records should be matching our query. So our query is mentioned. We want all the records that are greater than or equal to 1005. So that's why only these three records are being shown. Tell me, are you all clear on how you write the answer for this question? Yes or no? I shall start. So your marks, if you wrote it, if you drew the whole table correctly, put 2 marks there. Now tell me, out of 4 marks, how many marks are obtained? Others, if you have any questions, drop your questions in the chat. If you have any questions, drop your questions in the chat. Don't you have any questions? Drop your marks out of 4. Tuesday 5 p.m. class, did you start a new lesson? Database we started last week or week before the last. I can't remember exactly, but yeah, we're in database at the moment. Last week. One has finished database, but Delaware online I think started last week or week before the last. I can't remember. Online, what are you doing tomorrow? Online is behind actually. If you miss the physical, if you are coming, if you're getting absent for Thursday, you'll join the next Tuesday online class, not tomorrow. Anyone? So we're done for the day. If you have any questions, you all can stay and ask. Others, you all can leave. We're done. Any questions, anyone? I forgot to join online last. Why? I can understand. What do you mean by I can understand? Why? Do guided media has distance? Good question. Let's ask Google. To be honest, as I know, no. But let's see. Okay, this is the reason for the 100 meters issue. There is a 100-meter distance. I say no, it will weaken. It will be slow is correct. Actually, it will not be null. It will not be like the connection will not be off. The connection will get weakened mainly. The speed will reduce. But yeah, for a guided meter, there is a speed limit. Anything else? So yeah, this point is correct. Anyone having any other questions? No? Okay, so as there's no other questions, I'm going to end the meeting. If there's anything, you can WhatsApp me. Some of you have sent me some messages. I'm not still open. I will check it ASAP. Just give me some time. Anyways,